everyone, so welcome back to LeetCode with AK. So guys, actually due to the time constraint I can't able to attend the LeetCode week contest 353, but so after the contest is getting in, actually I started to read the problem statements was given in the contest. I found one of the problem is really more interesting. Actually I solved the problem, but the problem is really more interesting, so then I got the idea to create a video for that one. So guys, if you want the video for all the problems and all the problems been given in the weekly contest, please drop your comments. I will create a separate video playlist for that one. So meanwhile, so without waiting time, let's move on to this problem statement. So actually the problem is a LeetCode 2007. It was asked in LeetCode week contest 353. The maximum number of jumps required to reach the last index. Actually they are given a zero index array as well as a target. So what they are trying to say, so initially you position as index 0, okay, fine. So they will give the two input, one is an array, another one is a target. Initially you are stating at 0th index, okay, fine, that is my starting point. Okay, in one step we can jump from index I to any index j such that I less than I less than or equal to 0 and j less than n, and meanwhile it should satisfy the particular target. So don't confuse about the second point. And second point is nothing but the absolute value between the I number of absolute value between the jth value and the ith value should be less than or equal to target. So that is what they are trying to say. Please don't confuse with them, because the very first time actually while I am reading this problem, even I too get confused. The second point, it's nothing but the absolute difference between number jth and ith index value less than or equal to target. So okay, so let's say if you are in let's say I'm coming to this part. Okay, let's say 1 2 3 4. In that case, okay, in that case, suppose if you want to move, let's say this is I and this is j. If you want to move from I to this I to j, so what they are trying to say, it should satisfy one of the important constraint was given in the problem statement. And the absolute value between j minus I should be less than or equal to target. Okay, this is one of the important constraint. If you want to make a jump from I to j, definitely you can make, but before that you have to check this constraint. If the constraint is really matching, then you can proceed. There is some possibility jump from I to j. Okay, so now you understand about why they are giving this constraint. Okay, then return the maximum number of steps you can reach the n minus 1. If there is no way, just return minus 1. So what is n minus 1? N minus 1 is nothing but the last index. So we have to figure out the maximum possible jump from index 0 to index n minus 1. If your array index has a 4 index value, you are starting with index 0. Okay, you are starting with index 0. You have to figure out the maximum possible jump to reach from 0 to n minus 1 position. So that is our goal. So I will write this goal in our okay. So our goal is figure out the maximum jump from index 0 to index n minus 1. If not, return minus 1. Okay, so meanwhile from if we are making jump from index I to index j, in that case it should satisfy one of the constraint. So what is that constraint? The absolute value between the absolute value between absolute, the absolute value between number j minus number I should be less than or equal to target. This is one of the constraint. If you are making from jump from one index to another index, definitely the absolute value between that particular index should be less than or equal to target, otherwise you can't make. Okay, then you have to figure out the maximum possible way. If you take this example, the very first example, 136,414. okay, 136,412. okay, so now we are going to figure out the maximum jump to reach from index 0 to index n minus 1. Okay, let's move on to this. I will explain you each and every problem steps now. Okay, the very first step. Okay, for index 0, is there any other possible way to index 0? No, actually you are starting with index 0, right? That is what been given in the problem statement. So in that case, definitely you no need to consider about the very first index, because the very first index is your starting point. Okay, please don't consider your very first index, don't worry about that one. Okay, let's consider this one. Okay, so what are all the possible way to jump to this particular index? This is index 1, right? So what are all the possible way to jump to this particular index? So there is only one possibility, index 0, because there is nothing before index 0. So if you want to make a jump to the index 1, there is only one possibility, index 0. Okay, shall I pick this jump or not? Okay, that is my question. Why I am asking this question? If you don't know, please watch and think about that, because if there is a possibility for one particular plate to another particular plate, so what is the problem statement given in? Yes, it should satisfy this problem statement clearly. Only then, even though there is a possibility, first check, okay, this possible jump is satisfying my constraints or not. If it is satisfying, please pick this. If not, please don't pick. Okay, just check what is the absolute value difference between 3 minus 1 equal to 2, as well as our target. What is the target? Is between target is given as a 2 less than or equal to 2. Yes, 2 less than or equal to 2. Definitely I can pick this. Okay, I will pick this, don't worry, I will pick this. So what is the so for this particular index I equal to 1, I can make only one possible jump. That is also valid. So what I will do, I will simply add 1, which means there is a one jump required to reach this particular index. If there is a multiple jump, if there is a multiple possible way to jump to the particular, then you have to take the maximum value, because that is what we have to figure out, maximum number of steps required to reach the last index. Okay, let's consider this part. Okay, I will okay, just consider this part. Okay, so 6, the index I equal to index I equal to 2. Okay, in that case, so what are all the possible jump to index second index? So there is a 2 possibility, right? Either you can straight away jump from 0 to 2, or you can straight away jump from 1 to 2. Okay, so these are all the 2 possible jump. Okay, for 6 I have a 2 possibility. I can jump from 1, as well as I can jump from 3. So 1 is at the 0th index, 3 is as a first index. Okay, in that case, okay, again I'm asking the question to you. Okay, shall I pick this jump or not? If you are going to pick this jump or not, definitely it should satisfy this constraint. Okay, 6 minus 5, what is the absolute difference? 6 minus 1 equal to 5. 5 less than or equal to 2? No, definitely not. In that case, definitely I can't pick this possibility, because this is not satisfying my constraint. Okay, let's move on to this other part. Okay, 6 minus 3 less than or equal to 2? No, definitely, then I can't pick this value. In that case, so what is the possible way to reach the index 2? There is no way to reach index 2. In that case, you should mark minus 1, which representing minus 1, representing there is no possible way to reach this particular position. Okay, so okay, just erase this. Let's move on to the final one case. Okay, let's consider this part. No, not this part. Let's consider this one, the value 4. In that case, okay, what is the index? Only 0, 1, 2, 3. 3 is a index. third index. Okay, then what are all the way to reach index 3? There are four possible ways. There are two possible ways to reach that index. One is one, you can straight away jump from index 0. Another one, you can straight away jump from index 1, and you can straight away jump from index 2. Okay, then what you have to ask, just check the it's satisfying the constraint or not. Okay, 4 minus 1 3, it's not satisfying my constraint. Okay, just mark this as 4 minus 6 2, 2 less than or equal to 2, yes, it's satisfying my constraint. Just mark this. 4 minus 3, the absolute difference between 4 minus 3 equal to 1, 1 less than or equal to 2, yes, 1 less than or equal to 2. So definitely I will mark this as a green. So what are the possible step to reach 4? There are two possibility. One, you can jump from index first index. Another one, you can jump from the second index. Okay, then I will ask the question, which one I should pick? Okay, you should pick so what is being given, so you should pick the if you are jumping from index 1 to index 3, in that case, if index 3 has value 1, in that case, so I will tell you like this. Okay, I will tell you like this. Okay, 3 and 6 are possible way to jump. Okay, to reach the index to reach the value 4. Okay, if you are jumping from 3 to 4, the 3 already requires one jump, but there is a possibility to reach 4. In that case, what you have to do? Okay, 3 is taking 1. Okay, 3 is taking 1. Okay, but there is a possible way jump from 3 to 4th index. So in that case, what you have to? You have to increment the one step. Okay, so what is the value of 3? What is the number of jump to recover to reach 3? So initially, actually I targeted there is only one possible way which is satisfying my condition. So 3 is marked as 1. So which means there is a one jump to that one jump, it's a maximum possible way to reach the value 3. So in that case, if there is a possibility to reach 4, then you have to, what you have to add, then you are making one more step, right? In that case, you have just add plus 1. In that case, so it requires 2 jump to reach index 4. Okay, then what about this? The 6 doesn't have any required possibility, so please don't consider. So I got a 2 point. Now, 2 int. So one is like okay, first I have to first figure out all possible way to jump. Okay, and check constraints. Okay, the constraint is nothing but this was the constraint. So meanwhile, okay, that particular index should have valid jump or not. So what is mean valid or not? There is a possible way to reach 3, because 1 minus 3 2 less than or equal to target, there is a possibility. What about 6? There is no possibility to reach from 1 to 6. There is no possibility to reach 1 to 6 because of the constraint. There is no possibility to reach 3 to 6 because of the constraint. So there it was marked at -1. So -1 means there is no valid jump you can make it to reach the value 6. Okay, so check first what you have to do. You have to figure out all the possible way. Once you figure out all the possibility, just check which one is a valid, and then on top of that, just check our constraint being given in the problem statement. If all satisfying, plus add. So what that mean, plus add? The plus add mean, okay, I am standing this position, I am going to make a jump. Okay, this is valid. I said this is valid. If you are going to make one jump, it requires one more step, right? So let's say if this step having 3 jump to reach this step, then what is the answer to reach this point? 4, right? Because I'm going to make one more jump from this particular point, right? So the last point is like, okay, if valid, please add 1 from valid index. Okay, this is what we are going to see. Okay, so based on this, I hope now everyone clear about the problem statement, how we are going to solve it. Okay, now I will ask one question to everyone. So what is the, so based on explanation what I made so far, right? Now what are all the possible way we can solve this problem? Yes, so we are doing one process again and again. So what does it mean? Recursion, right? Recursion and backtracking tracking. Using recursion and backtracking tracking, we can able to solve this problem. Yeah, I'm pretty much sure with that. But there is a, okay, I can able to solve this problem. Then how we are going to solve this problem? Okay, if you're again take the same example. Okay, let's say if you are staying at this index, what you have to do, you have to iterate from year to year. Okay, you have to iterate from year to year. Check this is satisfying my constraint or not. Check this is satisfying my constraint or not. Is this is valid for make a jump or not? If this is valid part as well as if it is satisfying my constraint, okay, there is a possibility. Okay, if there is a multiple possibility, what you have to figure out a maximum jump. Let's say if 6, just imagine if 6 is a possible way to make a jump. In that case, what you have to do, 6 required 2 step and 3 required only 1 step. Which one is max? 2, right? Then you have to add 2 because I need to figure out a maximum jump to reach n-1 index. Okay, so I have to figure out. Okay, I will draw this the recursion tree, then you will clearly understand the problem. 1 3 6 4 1 2. Okay, there is a no possibility for a very first index because that is your starting point. It doesn't require any step. I will mark it as 0. And then what are the possible way to make a jump? For the 3, there is only one possibility, 1. So 1 minus 3 equal to 2. So I am going to add 1 step. So which means the 1 is doesn't require any step, and I am going to make one jump from 1 to 3. So it requires only one jump. Okay. So what about 6? 6 doesn't a valid part because 6 does not satisfying my constraint. So because of that, there is no possible way to move from the 6. Okay, so I just marked as a -1. Then what are all the possible way for 4? There are 3 possibility, 1 3 6, but 6 is not a valid jump because 6 was marked at a -1. I will simply omit this 6. I will simply, okay, then check the 1 and 3 is satisfying my constraint or 1 is not satisfying my constraint. 1 minus 4 equal to 3, 3 less than or equal to 2, definitely not. Okay, then only 3 is satisfying my constraint. In that case, what is the minimum jump to record 3? The minimum jump required to make a 3 is 1. Then 1 plus 1, you're going to make a jump from here. So plus add 1. In that case, so what is the value? So what the value would be 2, which means to reach the value 4, you require 2 jump. Okay, so what about this? What about this? What about 4? For 4, there is a how much was it? There is a 3 possibility. There is a 3 possibility. No, 4 possibility. 1 3 6 4. 4 was marked as a -1, so definitely I can't able to pick that. This is not a valid. Okay, 4 minus 1 3. No, that is not satisfying my constraint. 1 minus 3 2. Yeah, satisfying my constraint. So what is the possible way to jump from 3 to 1? 3 is required 1 jump, so 3 to 1 required 2 jump. Okay, this the value is required 2. So 1 minus 1 equal to 0. 1 minus 1 equal to 0. So yeah, satisfying my constraint, but required only 0 step, which means 0 plus 1 equal to 1. So what is the maximum value? 1 and 2. 2 is the maximum value, right? So you should update 2 here. Okay, then coming to the final part. Okay, then what are all the possible way to make a jump from here? So there are all the possible way. 1 3 6 4, again 1. Okay, so 6 is not a valid. I will simply unmark this one. So 1 minus 1 0, definitely require 1 jump. 2 minus 3 1, yeah, satisfying my constraint, but 3 already require 1 jump. So 1 plus 1 equal to 2. So what about 4? 4 already equal 2 jump. 2 minus 2 2, right? It's satisfying my constraint. So how much time the 4 is taking? How much jump the value 4 is required? 2 jump to reach the value 4. Again, you're going to make one more jump here. Okay, 2 plus 2 equal to 3. Okay, so among 1, 2, 3, which one is maximum? 3. Definitely 3 is a maximum. So without thinking that, I'm going to pick this one. So 3 is a maximum possible way to reach n minus 1 index. Okay, without waiting time, please okay, let's move on to this writing the code. Okay guys, actually if you clearly understand the problem statement, please pause this video, write a problem statement, write a problem in any particular language. Okay, actually I'm going to write the pseudocode now. Okay, pseudocode now. First what you have to do, you have for I to n, the very first time, actually what you have to do, you have to define one array. So dp array, nothing but, so before actually I said like, okay, this problem solving can be done by using recursion and backtracking technique, right? So I will ask one question. Okay, if it is a problem can be done by using the recursion and backtracking technique, then definitely there are some possible way, right? There are some possible way to solve this problem using dynamic programming. Then what are all the possible way to solve this problem using dynamic programming? You should ask two questions. The one is like, okay, whether the particular problem, okay, has overlapping subproblem or not. Okay, yes, the problem has overlap for every particular index. Actually I am traversing the same path again and again. So there is a overlapping subproblem. If there is a overlapping subproblem, then definitely if there is a overlapping subproblem as well as the problem can be solved by using recursion and backtracking, in that case you can simply solve this problem using dynamic programming. Dynamic programming is really the optimized version of recursion and backtracking. Okay, I will write a coding for this part. Okay, so the very first time I should create a DP array, right? Why I'm going to create a DP array? My DP array going to store the maximum jump for each index. Okay, so let's say number.length. Okay, I'll write a problem here. I simply close all this. Okay, constant dp equal to new array. So number.length, initially I will mark everything as a -1. So -1 is representing there is no possible way. Okay, the very first index record any jump. No, my very first index doesn't record any jump, so I will mark this as 0. So what I have to do, I have to try to figure out all the possible way for my possible jump for every index of my array. Okay, then for length for j equal to 0, j less than I, increment j. Okay, then what you have to do, you have to check whether it is satisfying my constraint or not. Math.absolute number.j minus number.j less than or equal to target. Okay, if it is satisfying my condition, then definitely dp.I equal to, I need a maximum value, dp.I, okay, plus dp.1 plus I. So which means if there is a multiple possible way, okay, I figure out one possible way, I'm just adding one step. Before adding one particular jump, just check is that you need to figure out the maximum possibility. Maximum, that is what actually we seen here. For 4, for making a jump to 2, there is a multiple possibility. Among all the possibility, you are going to pick the maximum one. Okay, but this is actually this is very simple and clear. Then finally you have to return dp of number.length -1. What you are returning? You are returning the final index value. If the final index value is not possible, definitely it will contain -1. So definitely it will return -1. If not, it will return the maximum possible jump to reach the n-1 index. Okay, so this is the code. The very first, actually I am declaring the DP array. Okay, the definitely my first index doesn't record any jump. No index, actually no jump record for this particular index. Then I am going to iterating. Okay, I have to start my iteration 1. Why I need to start 0? Because already there is a pre-calculated value actually added to 0th index. Okay, then I am starting from 1. If for any particular ith index, I'm trying to figuring out all the possibility. Let's say if there is a 1 2 3, okay, I where I equal to 3, in that case you have to figure out all the possible way from 1 to 2, 1 to 3, 2 to 3. So that is what actually we have been returning here. Now you may ask, okay, you are writing the nested loop, definitely it will require time complexity of O of n square. So just look at this, the constraint. Okay, the constraint is clearly telling you can solve this problem using nested loop, so which means O of n square time complexity. The constraint is really too small, so definitely you can able to solve this problem. If the constraint is 10 to the power of 4 or 5, in that case you should go for O of n time complexity. So what about the time and the final part, the time and space complexity? The time and space complexity definitely O of n. Okay, why O of n? Again I'm asking a question to you. Okay, did I create any array, as map, as set? Yes, actually I'm creating the array. So for if you are creating the array, that definitely the space complexity would be O of n. What about n? N stand for the length of the input array, I mean number array. Okay, so what is time complexity? The outer loop require O of n time complexity, as well as the inner loop require O of n time complexity, O of n into n, O of n square time complexity. The space complexity is O of n and the time complexity is O of n square. Okay, this is all about this problem. Thank you guys, thanks for watching till the end. Guys, if you solve this problem, please do your comments, so that is really mean for me. So meanwhile, if you stuck with anywhere, please ping me in the comment. Definitely I will reply back to everyone. So meanwhile guys, if you require any other separate playlist, or if you want me to create any particular video for any particular problem statement, please drop your comment. I will create a video for each and everyone. Thank you so much guys, thanks for watching this one. I'll meet you on tomorrow.